This mini lecture is about EZ isomers and designating EZ isomers, double bond compounds. First of all, let's talk about the relationship between rotation and E and Z. First of all, let's take a look at a CC single bond, and you can see that there's going to be free rotation around there. You've got the Cl on the same side, or you've got the Cl up here, and nothing's going to change as far as the name goes because we have free rotation of this atom around that particular bond. If we turn this into a double bond now, you can see the green atoms are now pretty much stuck where they're at. There's no free rotation going on here. We get a little bit of vibration, that's about it. We put the two Cl's on the same side. That's going to be a different compound now from two Cl's being on the opposite side of a double bond. Now, since there is no free rotation, it makes these compounds completely different. If these compounds are different, they're going to have different names, and we need to find a way to show those names and express those names to differentiate those compounds. So we have the possibility of cis and trans about a double bond, and that's when we've got hydrogens here. When the two hydrogens are next to each other, we call that cis. When the two hydrogens are opposite each other, we call that trans. You'll often see this in the case of double bonds in line structures. So if you've got a double bond in a line structure, the double bond will look like a U shape if we don't draw the hydrogens in. You'll have different things attached to the double bond, and that'll be cis. In the case of trans, the hydrogens will be opposite. Again, we don't draw the hydrogens in, and it looks like a zigzag shape when we draw it. So you've got to be looking out for both of these kinds of situations in your structures so you can differentiate between cis double bonds and trans double bonds. However, we run into a problem with a lot of compounds that don't have hydrogens attached to the double bonds. So we need to find a way to differentiate them based on a name, and what we use is what's called the EZ system. Now, the way this works is that we split the CC bond down the middle, and then we assign priorities to the atoms directly attached to the C's on each side of that split. So attached to this C directly, we have an F and a Cl, and what we're going to do is we're going to prioritize them based on their atomic weight. So the bigger the atom, the higher the priority. Cl gets priority 1, F gets priority 2. I gets priority 1 on this side, C gets priority 2 on this side. Once we do that, then we can then look at the relationship of the orientation of the ones. And we can see if the ones are on opposite side, we're going to assign that the letter E. E is German for entgegen, which means opposite. If the ones happen to be on the same side of a double bond, then we're going to call that Z. And Z stands for zusammen, which means the same side, and the way I like to remember it, zusammen equals Z. They're on the same side. If we are going to put this into a name, since this is an E compound that we've come up with, the ones are on opposite sides, we put the E out the front and then we complete the name. This is not something you'll have to do until later on. Let's look at a more complicated example now. Again, the first thing we do is we split the double bond down the middle. On this side it's easy. We've got an I, we've got a C, the I gets 1, the C gets 2. Now on this side we've got a C and we've got a C. We don't have a winner out of that, so we have no choice but to move on to the next atom attached to the C. Well, which atom do you choose? Well, you always choose the heaviest atom attached to the one you just looked at. So we look at this C, we've got H's and C's attached to it. The C is the one we choose because it's the heavier of the two. So here we've got a C, we've got an H's, we're going to move on to the C. Alright, so we were at the C's, we move on to the C, we move on to this C. Still no winner. So what we do is we look at this C and we ask ourselves, well, what's the heaviest atom attached to this C? Well, it's a C. What's the heaviest atom attached to this C? Well, it's an F. Since the F wins out of the F and the C, that makes this group the winner, so that's going to get our assignment as number 1. Since the ones are now on opposite sides of a double bond, we're going to assign this compound a letter E. Now things get a little bit more complicated when we have branching involved. Right, so we're going to do the same thing as we did before. We'll start out at the C's and the C's. Now we already know what's going on here. This will be 1, this will be 2. But we're looking at this one, the C and the C, and there's no winner there, so we move on to the next atom. And it's going to be between C and C, still no winner. Now, what we're going to have to do is, since this C has 2 of the same atom attached, it's got a C and a C, what we're going to have to do is we're going to have to move out simultaneously in both directions. But we're going to have to treat both of these carbons exactly the same. And let me show you a diagram of how that works. Alright, so here it is. Same thing. Right, we moved on to this atom here. And these are the two that we're actually going to compare. We're going to compare this one and this one. So we move on to this one and we move on to this one. We do this simultaneously. Now since I'm doing this to this atom where I'm going out simultaneously due to the fact there's 2 of the same atom directly connected to this C, what I'll do is I'll go out here and we compare to C to the C, no winner there. Now we compare this H to this C. Right, so that's what I mean by simultaneous. You've got to do C here, and we'll go out to the C here, and we go out to the H here. I'm only doing it on this atom because I had to do it on this atom. And I did it on this atom because I had the same atom attached to this C. I couldn't get a winner based on these, so I had to do it on this one and compare them. So I had the C and the C, no comparison, H and C, that's my winner. So this gets number 1 and this group gets number 2. So this designation would have also been an E designation as well. Let's take a look at another couple of examples. Alright, let's say I've got something like this. The difference, sorry, we'll do this one here. So over here, this one's going to be 1 and that one's going to be 2. Again, we split this down the middle. And now with this side, we're going to have, compare these two, they're the same, can't get a winner. These two, they're the same, I can't get a winner. But now, since I've got 2 C's connected to this C, I'm going to have to go out simultaneously. If I go out simultaneously on that one, I have to go out simultaneously on this one as well. So I'll go out here, and I'll go out to this atom here. I can't get a winner out of these 2 C's. Now I'm comparing this C to the H, so this one is going to be the winner. So that's going to be 1, that's going to be 2. This one will have a designation of Z. Now let's say you've got 2 branching chains. We'll have 1, we'll have 2 on this side, and over here I'll compare the C, to the C, C to the C. I won't get a winner out of that. But now I've got a C that has 2 things associated with it, so I will go out simultaneously to each one. And again on this one, I'll have the hydrogen here. I have to go out simultaneously to that one and to that one. So what's going to happen is that I'll go out to this C and to this C. I won't have a winner. I'll go out to this C and this H, and I will have a winner. So this will end up being the top priority. That'll end up being the second priority. It's pretty easy to tell. If you've got two branch chains, whichever one branches first, and it doesn't matter about the length of the chains either, whichever one branches first, that's the one that's going to be the one that has highest priority. If you had two things that had different length chains, so we just do longer chain here and down here, it's going to be fairly easy to see that we'll compare this to this, we won't have a winner, compare this to this, we won't have a winner. But now we've got a hydrogen attached to this one, and we'll compare the C to the H, and this one here would be the winner, so that would get priority 1 and that would get priority 2. So if you've got two chains, the longer chain, and they're not branched, the longer chain will always win over the shorter chain.